So let's begin. So Mario Constanti presents on tiny containers, big problems, of course. Please go ahead.
So hi everyone, I'm Mario, I'm a software engineer at Mercedes-Benz Tech Innovation, which is a 100% subsidiary of Mercedes-Benz, so the car company. But today it's not about cars, it's about container images, and why minimal container images are awesome, but at least in the past it was very hard to troubleshoot an application when you have nothing in the container, expect the application. And the talk is mainly about a feature which got introduced in Kubernetes 1.30. They introduced a custom flag in the kubectl debug subcommand. And the cool thing about it, it's just a kubectl feature. So you can use that feature on older clusters as well. The only requirement is you have a Kubernetes version where ephemeral containers became a thing, but I think that's ages ago. So what's a container image? And this is from the Docker documentation. And to be honest, it sounds super great because a container image only contains all the stuff your application needs. So the binaries and the libraries and the configuration. Nothing more, nothing less. So what should be in the container? The application and all the dependencies. So that's the theory, and the theory is awesome. But on the other side, you do not have to take care of CVEs of your application, of CVEs of the container image, which really do not depend on your application. And also what's quite cool, this also reduces the attacker surface of your application. So because an attacker can't explode or can't spawn in shell when there is no shell in your container. So that's the theory. But the practice is quite different, and a lot of open source projects, and even myself, I've built a lot of container images based on Alpine or Debian or Ubuntu with a shell, and I wanted to have the core utils because I want the most awesome hacker command in Kubernetes, base64, and all that other cool stuff like curl or OpenSSL if you want to debug or troubleshoot some certificate issues. And now I want to take you on a small journey. So how an application built with a minimal container image, how can we debug them without losing all these cool tools and without rebuilding the application from scratch? Exactly. So I hope everyone is able to see my screen. Yeah, that also works. So we have a small application running in Kubernetes, and if I want to access the application, I got a very, very bad internal server error for some reasons. So the first thing I mostly do is check the logs, but the logs are some kind of boring, so nothing special is in there. So we have to talk with the developer, improve the logging, but that's another topic. So the first thing I mostly do is exec into the pod. And we see the developer has done a very good job, so there's no shell in the container. So how to continue? So at least what I have done in the past quite often, and I know a lot of folks have done that, very similar. Come on, let's build the application again. Let's build based from an Alpine image or something like that. Sorry, that's not too far. That one. No. Come on. Yeah. So let's rebuild the application again. And we see here, okay, we changed the image and we built from scratch or from distrolets to Alpine. And what we might see here is, okay, now we have some CVEs. And this is because we moved security to the left, and now we build all the container images after build and scan for CVEs. And now I have to deal with CVEs. And to be honest, right now I do not want to deal with CVEs. I want to fix my application. So how to continue? So before this custom debug, before this custom flag, it was possible to just use kubectl debug. You see that? You saw that here before. Here, it's just kubectl debug, and I use this netshot image on my web app pod. And now I'm in my container, and I share the process namespace, so I'm able to see the app, and I also see, we do not see that. Okay, there's a template flag. Come on, too large. Oh God, I hate the laptop keyboard, as you see. So there's a template flag, and this template flag points to a config directory where there's a template file in there. And we know the application a bit, and we assume the issue might be because of that. So, and we also know this template got mounted from a config map, but it could be also mounted from a secret or another volume mount, for example, from a PVC or something like that. And we also want that mount in our debug session. So what we now have to do is we have to prepare our debug session with this custom debug profile. And to achieve that, we just have to prepare a debug profile. Okay. And the debug profile is quite simple. It's just a container spec. And as you see, the most important part is the volume mounts, and we only want the volume mount from the app config map mounted in our container /conf. I can add other bunches here, like the security context or some additional environment variables, as I've done below. But for now, it's not important. The important part was mounting the config map into the debug container as well. And to see how that works, I just have to run this small command line. So debug my pod with this custom profile app profile config JSON, so the JSON we've seen before. And when I do that, so I attach a new container, a debug session into the running pod. I can still see that. And now I'm able to cut my and all the people who know Go template already see the issue. I missed a dot in the remote address template field, and that's why my Go code can't render the template. So we have to fix that. And this was just able, without rebuilding the application, we can see everything the container has. And so the next step is fixing the container. I already prepared that. Apply the web app again. Restart the port forward again. And now we are able to see. And now we are able to do the curl, and we get a response from the server. And that's it. I do not have to rebuild the application. I just change the configuration of the config map, and that's it. And with that, I was able to debug that issue without rebuilding the container. So one last thing. I personally found that some kind of annoying having this long command line, and I was so hyped about that feature from an application development point of view. And I told a lot of people in the company, hey, that's so cool, you can really use minimal container images. You just have to maintain some kind of a debug container, and you can share that debug container with other teams. You just have to maintain this debug profile. And I found that it's some kind of annoying having this very, very long command I always have to type. And I've decided to build a small tool to manage a bunch of these debug container things. And it's an official kubectl plugin. And again, we are to. Okay, and this is my configuration where I have a bunch of debug profiles. I have a debug profile for Prometheus installation. I have a debug profile for my web app, and I also have a debug profile for when I can debug an application with the default profiles which already exist in Kubernetes. And yeah, And with that, you just have to maintain a generic configuration by your own, and then you can share the debug profile with others. And yeah, and I very often forgot some debug profiles I had, so that's why that tool helped me a bit. Yeah, so that's it. Sorry. I know I'm in the debug container for sure. Here. So, okay, 10 minutes left. Perfect. No, I'm over time. Sorry. So this is the direct link to this tool I've written. If you have any question, I'm still around here. If you have questions, just ping me. I'm on Slack on the CNCF and also on the Kubernetes Slack. Just ping me or ask me here. So I'm happy to answer your questions. So that's it. Thanks for having me.
Thank you for the presentation. So we are switching to the next speaker.